Okay, so welcome to another lecture of FYS2101. Nope, just starting to talk now, Abdullah. Okay, so today we're going to finish off chapter 2 by looking at the cross product. And after that, we're going to continue by looking at, by starting chapter 3, motion along a straight line. Okay. Active. Okay.
Doctor,
Yep.
which section will include from chapter 2?
In where?
From chapter 2, which include?
All sections, as in the work plan.
Okay.
تعريف الحفظ العنود. So in general, there is no memorization. I'm not going to be asking you at what date this happened or things like these. The equations are given overall, okay? But you need to know, to understand how they work, okay? So I will not tell you memorize, for example, the mass of an electron or a mass of a proton. But if you need to use them, you'll be expected to know how to use them, okay? Definitions, no, you're not expected to memorize definitions, but you are expected to understand how do they work. Okay, so I will not ask you define, for example, define free fall, but if I give you 2 or 3 scenarios and I tell you, okay, which one of these is a free fall, you need to have understood what does a free fall scenario mean to be able to understand that question. Okay, of course, we haven't studied free fall yet, so this is a bad example, but this is the simplest thing I could think of. Okay. So yes, Dina, you can find an example, an exact copy of what is going to be provided on Moodle. I have uploaded it there. Okay. My computer is being unresponsive. Sorry, give me a second. Trying my best here. Close, 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 close. Please work. Okay. So towards the end, we reached cross products, and we started talking about them, but we didn't have time to finish. So this is what we're going to be doing today. And God. Okay, here we go. So we defined a vector product to be A cross B, and we said that its definition is if we have two vectors, A and B, at some angle phi between them or theta between them, we do A cross B, we get a third vector, C, which has a magnitude of AB sine theta. Okay, this is going to be its magnitude. So how long it is, if you want, in a graphical representation. And the direction of that vector is going to be perpendicular, i.e. at 90 degrees, to both initial vectors, A and B. Okay, so another way of thinking about this, which is in your book, is if I have a set of axes and I have two vectors, A and B, with some angle theta between them, and I try to continue this in a parallelogram as such, I will get a third vector coming out of the page, okay, and its length or its magnitude is going to be AB sine theta, otherwise known as this area of the parallelogram encompassing both vectors. Now this direction thing is a bit confusing, okay, so we'll try to do it one thing at a time. First thing first, it's always going to be perpendicular to the direction of both vectors. So if I have vector 1, vector 2, vector 3 can either be coming out like this or like this. It cannot be at any other angle because it would not satisfy the condition that it be at 90 degrees to both of them. Okay, so it cannot be this way because it's only 90 degrees to this blue pen, but not to the white pen. Okay, it has to be at 90 degrees to both of them together. This way or this way. Yes, A and B, I'll come to it in a second. The order of A and B are very, very important, and I'll tell you why in a second. So usually when we come to multiplication or addition or subtraction, if you remember at the very beginning of the chapter, I told you one of the properties of the dot product or of addition and subtraction of vectors is that they're associative and commutative. And I said A plus B plus C is equal to C plus B plus A. When we spoke about the dot product, I told you that A dot B equals B dot A. So far, so good? Now, the exception is the cross product is not the same. A cross B is not equal to B cross A. They're not the same, and this is very, very important. As a matter of fact, remember 2 minutes ago when I told you this way and this way? And I told you that if I have these two vectors, this can be either this way or perpendicularly to the back. A cross B will be one direction. B cross A is going to be exactly the opposite. Okay? So if this is A cross B, this is B cross A. If this is A cross B, this is B cross A. It's going to be in the opposite direction. So if we want to define it, we're going to say that A cross B is equal to minus B cross A. Why? Because remember that the result of a cross product is another vector, which means it has a direction. So although the magnitude would be the same, the direction would be different between A cross B and B cross A. Okay? So we have one vector A, one vector B. The A cross B is the green vector perpendicular to both. Now the question is, in which direction? Is it? How do we know when is it in this direction? When is it in that direction? Now I've already told you this. B cross A equals minus A cross B. But where do I know? All this tells me is one is up, the other is down, or one is left, the other is right. But when is it left and when is it right? How do I know? And for this, we use what I call the right hand rule. Okay, we use our right hand and we use the index finger, the middle finger, and the thumb. Between these three, we are able to figure out the direction most times. Okay, in this course, we're not going to be looking at left-handed coordinate systems. So in this course, at all times, these three fingers are all you need. Okay, some books do it with equations, other books do it with hands. I do it with fingers because I find it easy. And to remember it myself personally, I use what is called the threatening rule. So if I want to, if I'm speaking to someone, to a little child, I want them to do something and they're not doing, I usually try to warn them by telling them 1, 2, and this is how I start counting. I do the exact same thing here for vectors. I start counting using this finger, my index finger. This is my, then I go to the second finger, and my result is always going to be the thumb. So let's do a practical example with my two trusty pens. Okay, which one do you want to be one? A. We have vector A and vector B. Which one is A? Which one is B? I'll have blue A, white B. Okay. A is up, so the direction of the cap. Actually, let me do this. The direction of the pen is where my arrow is. Okay, so this is up and this is going that side. So first finger goes in the parallel to this, in direction to this. Second finger is at 90 degrees. Look how it is. There's a 90 degree here. Okay. It's with the second thing. Now this is very difficult because I only have two hands. I wish I was an octopus at the moment. So like this, 1, 2, and my thumb is going to be backwards. So this is the direction of my vector. Okay, we seem to be having another technical issue. Now, look at the camera, not at the screen. But otherwise, what I'm going to be doing is I'll stop presenting for a minute. Okay, so I took the sharing off, so we can take a look at it like this. So 1, 2, 3, these three fingers. Okay, this one goes with vector A, this one goes with vector B. Wherever my thumb is going to be vector C, the result. So I'll do it again. Vector A, vector B. Okay, right hand, always right hand. Okay, so 1, 2, so because this is the direction of the tip is where the direction of my vector is. 1, 2, and my thumb is going to be to that side. So this is vector C, this is the direction of vector C. Okay, now what happens if I mix it up between 1 and 2, between A and B? Okay, let's do B cross A. So 1, the first vector that shows up. 2, and my thumb is now in the exact opposite direction. Okay, so A cross B, B cross A. Okay, it will take you some time, to get used to it, and you will have some carpal tunnel syndrome with this thing. Your hands will hurt, but it will work. This is in the cross product only, Nama. Yes. Nama, sorry, I don't know, these are English names. Okay, this is only in cross products, not in dot products. I'll share the screen again. Okay, now one question I often get is, okay, is there an easy way to remember the rules? Okay, and I'll share with you, I'll first show you a few ways that some books do it, and then I will share with you my way. So this is how one book does it. They use a full hand, not 3 fingers. They do A, B, and then this is C. So they use the full hand instead of 3 fingers. I find it easier to use 2 fingers that are at 90 degrees than 1, 2. Okay, so if I have I and J, then the result is, let's see, I, J, sine phi. Phi is 90 degrees. So sine 90 degrees is equal to 1. So I get IJ 1, which means that I cross J is simply in the K direction, up. So I cross J equals K. Okay? So far, so good. Sine 90 equals 1. Nice. Fine. What if I do the other way around? Same vectors, but other way around. J cross I. It's still 90 degrees, but now we're going in the opposite direction, from J to I. So it's actually 90 degrees. So exactly. So the result is J cross I is equal to minus K. Now I do the same again with JK. I get plus I. I'll do the same again with KJ. I will get minus I. I will do it again. IK. Let's go actually the other way around. KI. I will get J. IK. I will get minus J. Now these are 6 rules. And I don't know about you, but I really don't like remembering rules because I'm really, really bad at remembering. Okay? So this is a summation of the rules. Going one way is plus, going the other way is minus. You have a triangle. Okay, this is one way to do it. My way to do this is the following. I write I, J, K, I, J, K, I, J, K. I just write it 3 times. I, J, K, I, J, K, I, J, K. And I have a very simple rule. Going forward is positive. Going backward is negative. So let's actually do this in a whiteboard so it's easier to see. I will write I, J, K. Let me write them further apart. I, J, K, I, J, K, I, J. Okay, help me out here. I want to go from I to J, I cross J. What is my result? I cross J, K. Excellent. Positive K. What if I go J cross K?
J. Yeah.
I positive.
I. What if I go K cross I?
J.
Simply J. So far, so good?
Yeah.
Okay, now let's go in reverse. I'll use a different color. Okay. Now I want to go instead. So it loops. Okay. Now I want to go j cross I. What do I get?
minus k.
Minus k.
Excellent. Minus k. What if I go I cross k?
Minus j.
Minus J.
Minus j. And k cross j will get me
I.
minus I. Right? So far, so good? This is my personal way of doing it. I have been doing it for over 15 years now. It hasn't failed me yet. Okay? I just write them down. نروح سيدا positive, نرجع ريوس negative. Okay? No need to remember triangles. No need to write 6, 7 different rules. Whenever there's a cross product, even me when I do it in a test, or me when I do it when I prepare for this lecture, whenever there's a cross product, in the corner of my page, you will see IJK, 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 and arrows. Okay? So, to summarize, a vector product, A cross B, will have the resultant as a vector C. You will see in a minute. No. Okay? It comes a lot in engineering, in science, like even the simplest of things these will come in later on. Okay? So to summarize, A cross B, the resultant is vector C with magnitude AB sine theta and direction given by this right-hand rule. If you decide to do it the other way around, B cross A, then your result will be with a negative. Now the question is, very good, but if I have two vectors, how do I actually do them? How do I actually do it? And it doesn't look very nice. This is the final result. A cross B, if you have two vectors, each one of them has I, J, and K, this is your result. Your I component will have AY BZ minus BY AZ. Your J component will have AZ BX minus BZ AX. Your K component will have AX BY minus BX AY. And I can already hear alarm bells in your head ringing, as in what on earth, how do we remember this? Yes, we go do it the matrix way. What is the matrix way? Remember well, if you were with me in the tutorial yesterday, we used a matrix way of writing. Okay. So I'm going to do this from scratch here. So don't worry if you're not in section 21. I'm still going to be doing it from scratch. Let's say I have a vector A with components AX, AY, and AZ in 3 directions, X, Y, I, J, and K. And then I have a vector B, exact same thing, but with different components. I can write it in such a way. I can write a matrix where my heading, I have a heading at the top, N1, I, J, K, and then I simply write it this way. Okay, I haven't actually done anything. I've just rewritten it. So far, so good. Is everyone happy with what we have done so far? This is important before we move ahead. Yes, yes, yes.
Yes.
Okay. All right. So if we're happy with writing it this way, it makes it very, very easy for us to do the calculation now. So new page. These are our 2 vectors. This is our heading, and I want to calculate A cross B. So what I do is, we know it's a vector, right? The result is a vector. So my result will be something I, something J, something K. So far, so good. It's a vector, so it's going to have components. Now, what are the actual components? How do I calculate them? Well, let's say I want to calculate the components for I. Okay. What I do is I hide the existing components for I. So I hide the title and I hide the I, like this. I am left with 4. What I do is I do an X. AY, BZ, minus AZ BY. I'll write it down. AY BZ minus AZ BY. Now I want to do the same with the J. I will cross off the J and I will do AX BZ minus AZ BX. Want to guess what we do with the K? Exact same thing. And we end up with that. Okay. So do not try to memorize this AY, BZ, AZ, BY thing. Just do it the matrix way. You don't need to remember anything. You just need to write it in a neat square and then go X. That's it. Now, you ask me, why is it important? And I'll do something. I'll take 2 minutes to show you why. I will just Google cross product uses. I'll go to Google to Wikipedia and go cross product. Where can we use the last way? The matrix way, you mean? Anytime there is a cross product, you can use it. Okay. So definition, computing, matrix notation, blah, 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 geometric meaning, triple product, infinitesimal generators, alternative ways. You can see there's a lot of things here, but this is not the important. Where is it? Useful. Applications. Okay, thank you for letting me know, Ali Mama. I will try to slow down. Okay, I will try to slow down and I will upload these as usual. Okay, so in computer graphics, this is useful for calculations. Let me give you 2 examples which we will actually use later in this course, okay? One is angular momentum and torque, okay? Lorentz, we don't actually do Lorentz force. Let's stick with angular momentum for now. I'll tell you an example. Okay. Have you ever tried to unscrew something that is very, very tight? Say, for example, a gas cylinder or something, and you're trying to unscrew the lid, and it is very, very tight. Now, your solution, usually, I'm trying to find something here, give me a second. Now, your solution usually would be to use something like this. Yes? To try and hold it and move it. Now, have you ever wondered why is it easier to unscrew that very tight thing if you use something that is longer? So if you are if you know about spanners, you will know that you have ones that are about this long, then you have longer spanners, and you have ones that are about this big. Okay, why is it easier to unscrew something if you have a longer screwdriver instead of a shorter screwdriver? What is the point? Why is it easier to unscrew something if you have a if you have a longer spanner rather than a short spanner? The reason is the actual calculation that goes into this is torque is equals R cross F. So although, let me go back to the presentation. So say you have some sort of, what's happening here? Uh-oh. This was a mistake. Start a new board. Okay, so let's say you have some sort of cog like this. You use a spanner that looks like this to open it. The actual equation that we're going to use later in this course is torque equals R cross F, where R is your moment arm, the length of this, and force is the force you put here. And there's a very good reason why you want to do it at a 90-degree angle, not at any other angle, because at 90 degrees, your sine theta is equal to 1. So you are maximizing this force. And the resultant is, well, your screw ends up going upwards. So you're giving it a torque that is going up. Okay. You need less force because you're doing the cross product with R. Okay. We'll go through this later in the course in some, I think it's chapter 9 maybe, or something like this. And you will see in effect when we use the cross products. For now, we move on to chapter 3, motion along a straight line. Now, in the study of motion, everything's moving in the universe. Left, right, everything is moving, okay, even if we don't see them. And generally speaking, we want to talk about two things. What we call kinematics and dynamics. And the total of these two is what we call mechanics. Okay. Now, since the Stone Age, people were fascinated with, or even before that, since the beginning of humanity, people were fascinated with mechanics. Why do things happen and how do they happen? And we will be looking later on in this course at why do they happen in the chapter titled Newton's Laws of Motion. But to start with, we can look at how they happen, how they move, how they do stuff, without understanding why. It's just like a little child. You put your hand on a hot thing, it hurts. You learn. I will never put my hand on this thing again when it's glowing red because that means it will hurt me. I have no idea why it hurts me. I don't know the physics of it hurting me, but what I do know is doing this again is probably a very bad idea because two things. One, because it hurts me, and two, because if it hurt me this time, then there's a very good chance if I do it again, it will hurt me again. And this is exactly how we start the learning of physics and of mechanics, by seeing how things work and trying to describe them using equations that work over and over and over again. And we will start by doing this in 1 dimension, then go to 2D, and then go to 3D. So, kinematics, how objects move. Dynamics, why do they move? So far, so good? Now, we have two types of motion. One is like this, when a child slides on a slide. And another one is like hamster on a hamster wheel. And these two types of motion are rather different. One is called translational motion, and the other is called rotational motion. Now, again, we will break it down. We will start this course by looking at translational motion, and then later on, we'll go to rotational motion. Someone sent something? No. Okay. Here's a ball, and it's moving. That was quick. It's happening again. Take a look at what's happening. It's going like this, and from here to here at the same time. It's doing both of them together. Translation from one place to the next, and rotational, it's going in circles while it's doing so. So let's do some examples of translational motion. Here's an example of a one-dimensional translation motion. A train on a train track, when I look at it from a side, it's not going left and right, up and down, it's just going in a straight line. So that's one-dimensional translational motion. Two-dimensional is when something is moving, for example, in a lake. Okay, it's going left, right, forward, and backward. That is two-dimensional. Three-dimensional is when a helicopter is, for example, flying. It's going forward and backward, left and right, and up and down. So in all three axes, X, Y, and Z. Let's start with one-dimensional. I have a car, for example, going backwards and forwards. I have an apple that is going up and down. Just making sure this thing is working. Okay, it is working. Okay, and what we do is we assign them names. Anything that is going like this, we'll call it the x-axis. Anything that's going like this, we'll call it the y-axis. Why did I call them X, Y, not A, B, or DF, or smiley face, sad face? It's just convention. If I want, I can call this smiley face, and I can call this sad face. It makes zero difference in physics or in mathematics. Okay, it's just names. We give it. Okay. Now what we do is we assign the 0 point. We choose a place where we call this place is the 0 point, and if I go in this direction, it is positive. Now, again, why do I have the arrow going this side? Why not that side? Again, convention, choice. I could do it the exact opposite way, and it would make no difference whatsoever. Okay, so far so good. We call this a coordinate system. The XY axis or XYZ, we call it a coordinate system. Okay, let's think of this person who's moving. Okay, and then the same person is going to be coming back and stop here. So this person went about 70 meters one way and then came back about 30 meters. We have already spoken about these two things, but today we will introduce them formally. Distance and displacement. What is the distance traveled by this person? 40, 100, 100, 100. So the distance traveled is 100. Okay, because he went 70 and then 30. So he moved 100 meters. But what is the displacement? Otherwise known, what is the useful thing? What is the end product? Only 40. Someone tried to write something. Okay, yeah. All right, perfect. So we know the difference between distance and displacement. Distance traveled is the total amount of movement done. So we go from x1 to x2 plus x2 to x3. 70 plus 30 is 100 meters. It's only positive. Distance cannot be negative. Distance is a scalar. It can only be, well, I've moved 100 meters. There's no meaning for me saying I moved minus 100 meters if I'm talking distance. On the other hand, displacement, okay, is defined as, now this is the formal definition of displacement, final position minus initial position. So my final position is 40 meters, my initial position was 0 meters, so my actual displacement, delta x, is equal to 40 meters. It can be positive, it can be negative. So for example, if I went 70 meters this way, and then I went 100 meters this way, I will end up at position minus 30 meters. So my displacement is going to be minus 30 meters from where I started. It can be positive or negative. How do I write displacement? I will write it delta x equals x2 minus x1. This is the Greek letter capital delta, and all through mathematics and physics and chemistry and many other places in sciences, it means change in. So delta x means change in x. It's x2 minus x1. Okay, here's an example of a positive displacement. Here's an example of a negative displacement. Let's see if we have understood this. Distance and displacement from my room to the supermarket. My room is located 250 meters from a supermarket. I walk from my room to the supermarket, I come back, which is true. My distance is 500, displacement is 0. Distance 500, displacement 500. Distance 0, displacement 500. Distance 0, displacement 0. Excellent, perfect. Most of us has understood this. Okay, pretty much everyone has understood this. This is excellent. My distance is 500, my displacement is 0. Now, you might be asking me, okay, what's the point in differentiating between distance and displacement? It will come out in a minute. Okay, we have about 20 more minutes. Okay, we have time. So, measurement of time. Let's introduce a new concept. Well, new in terms of this course, we all know what time is. We have introduced the concept of position. Now we introduce the concept of time. Measurement of time. How do I measure time? Stopwatch, clock, how much the sun moves, different ways. Let's stick with stopwatch for now. Stopwatch or clock. I start at t1 equals 0 or on a clock at a certain time, say 9 a.m. It moves a bit, 10 minutes. We all know how to read a stopwatch or a clock. I'm not going to lecture you about that. And the change in time is 10 minutes. Very simple. This is stupid. Bear with me. So now we have two different definitions we have learned so far, delta x and delta t. Now what happens when I put them together? I get the concept of how fast is something moving. Okay, speed and velocity, which are two very different things. Yeah. Speed and velocity, when we talk every day, we use the two words interchangeably as if they are the same thing. But in physics, they are very, very different. Okay, it is the definition between بين السماء والأرض. They're very different, and we'll show you why. Let's introduce the concept of average speed and velocity and look at the difference. Speed is how far an object travels in a given time interval. So average speed equals distance traveled over time elapsed. So far, so good? No problem? Excellent. Someone already wrote distance over time. What about velocity? Velocity, speed is scalar. Okay, velocity is a vector. So we need direction. So we cannot use just distance. We need to use displacement. Excellent. I see a few of you are writing it. Okay, we need to use displacement. Now, 1 second. Your chat's screen has suddenly decided to go off. And we're back. Okay, so velocity includes directional information. So now if we go back to our example of that person going a distance of 100 meters but a displacement of 40 meters, what I get for speed and what I get for velocity are two very different numbers. Say, for example, this person, it takes him 180 seconds, 3 minutes to go 100 meters. I mean, he's fat, so it takes time. All right, so distance, 100 meters, displacement, 40 meters. Speed is 100 over 180, 0.6 meters per second. But average velocity is 40 divided by 180, not 100, which means it's much, much slower, 0.2 meters per second. And as I said in the example a few lectures ago, if I am going from here to Suhar, okay, this speed of 0.6 meters per second is going to be very useless to me because, in fact, I'm not going 100 meters. I'm actually coming back 30 meters every single time. So this is what I will need to calculate how much time it takes me to get from here to Suhar. Okay, so average velocity, displacement over time elapsed, final position minus initial position over time elapsed. We denote it V bar or V average. So far, so good? Unit is meters per second. If the object is moving in the positive direction, velocity is positive. If the object is moving towards the negative direction, then velocity is negative. Fine. So far, so good. But now here's a question. But now here's a question. How useful is this? Say, for example, I want to know the velocity of a car. You can tell me at my average velocity, my total distance from Muscat to Suhar is 250 kilometers, and it took me about 2 hours to go there. So that means my average speed was 250 divided by 125 kilometers per hour. Okay. But is this really what happened? Was your car going 125 the entire time? That is basically impossible, because when you left home, you couldn't go 125, your car was stopping. Then it moved a little bit. Because I know it's 250 kilometers. Give me another place and give me the distance. I'll use that. Okay. So, I forgot what I was saying. Okay. So what actually happened is my car started from 0. It went up. Shawara Dakhili, it was going 20, 30 kilometers an hour. Then it went up to like 40, 50. Shara Al-Am, maybe main roads, 80, 90, 100 if there is no traffic. Okay, once you go to the expressway, then you go all the way up to, if you're a legal law-abiding citizen, 120. If you are skirting it, 130. And if you are a normal Omani driver, then probably 150. Okay? So, what do we call these different velocities? My average velocity is going to be 125, but where do we call, what do we call these intervals? We call it instantaneous velocity, and keep that term in your mind because I will be coming to it, back to it shortly. Actually, أنا من مطرح. So 250 is just an easy number to remember. The distance to Matrah is what? 12, 15 kilometers? Not useful for physics problems. Okay? All right. Okay, so Before we go to instantaneous velocity, let's look at graphing. Okay, let's draw some graphs and get some graphical sort of feeling to what's happening. X as a function of time. The more time goes, the more I'm going to move. I'm going to draw it. Time is going to be on the x-axis, position is going to be on the y-axis, which is very confusing because this is x, but it's on the y-axis. Okay. So let's draw it. I start from here, and I keep going this way. I draw a straight line through it, just like we did in the lab. And I have multiple time differences. And my average velocity is my total change in displacement over my total change in time. But what happens? Yes, it's also the slope, Sultan, excellent. Now the question is, what happens if I have something weird looking? So this is a very nice straight line without a problem. What happens when I have something like this? Okay, now this is not a straight line graph. What it means is, if I want to know the velocity, okay, so here my slope is constant, right? My slope is the same everywhere. So my velocity is constant. And if I draw it on a velocity time graph, I will just have a straight line. But sometimes I have a velocity time graph like this, where the velocity is not constant. Okay. Now, here comes instantaneous velocity, i.e., what is my velocity at this point? Or what is my velocity at this point, or this point, or this point, or this point, or this point? Each and every time, my velocity is different. Okay, if I read my velocity here, it's going to be one number. If I read my velocity here, it's going to be different number, and so on and so forth. Okay. So some people are saying, look at the area under the curve. Some people are saying, look at a tangent line. Okay. Now, let's do it first thing first. Let's go back to our nice position time graph. Okay. And do something. We defined our average velocity as delta x over delta t. And let's just make delta t very, very, very small. So instead of, what's the distance from here to Surah? I'm going to change Sahar. People are upset now. Okay, I'll use 250 again. Okay. Let's say instead of taking 2 hours for the 250, okay, I am going to take 10 hours for 1,000 kilometers. Easy numbers, 10 and 1,000. I'm going all the way to Salalah, all the way to the south. Okay, I'm going to take 10 hours, 1,000 kilometers. But now, instead of looking at the full 10 hours for the full 1,000 kilometers, I will make it slightly smaller. What about for the first 5 hours? What about for the first hour? What about for 5 minutes? What about for 2 minutes? What about for 1 minute? And at one point, I can make the time interval smaller and smaller and smaller and smaller and smaller, all the way until I get to delta t that is almost equal to 0. Okay, and we write it mathematically like this. Velocity, note that this has disappeared now. Okay, we have disappeared. Notice this line has disappeared. Okay, so velocity is equal to delta x over delta t, where I am looking at the limit of delta t going to 0. This is also known as differentiation, dx by dt. Okay, so we started by saying total distance over total time, and then if we reduce the time over and over and over again up until very small, we end up with a differential, dx over dt. Oh, we're just starting, nihayat and bidayat. We're going to see way, way more of these in sciences. Okay, so dx over dt. What is dx over dt? I have a graph of position over time, and I have something that looks like this. What is dx by dt at any given point? Any idea? No one? Dx by dt, the differential of my function, is the same as taking a tangent line. So my dx by dt at this point is the tangent line here, or otherwise known as the slope or the gradient. Or in this case, our gradient, our slope is velocity. Let's do a PIQ to see. Say we have a position equation. Okay. The following equations give the position x of t of a particle in 4 situations. X equals 3t minus 4. X equals minus 4t squared minus 2. X equals 2 over t cubed, and x equals minus 2. In which situation is the velocity of the particle constant? In which is v in the negative direction? So 4 and 1. Okay. Excellent. Perfect. So we take the derivative, and for the first part, okay, where is the velocity of the particle constant? The derivative of number 1 will just give us the number 3, so 1 is correct. And the derivative of number 4 will give us 0, which technically is correct, but if my velocity is equal to 0, it means I'm not really moving. So it's not really, you know, it's not really a constant velocity. It is just 0 velocity. I'm not moving. I don't have any velocity at all. So the correct answer is 1. Part B, in which situation is the velocity negative? Well, to have a negative velocity, and I have the function for x, for position, or for displacement, I need the derivative, and you are all, let's see. You are all correct in one way or another. Both 2 and 3 are correct. So x equals 3t minus 2. X equals minus 4t squared minus 2. X equals 2 over t squared. And x equals minus 2 dx by dt. This will give me 3. This will give me minus 8t. This will give me minus 4 over t cubed. And this will give me 0. So this one is negative, and this one is negative. Okay. Don't forget that if we have, I will actually upload something on differentiation on Moodle as a quick revision for those who have forgotten from high school. If I have x equals 2 over t cubed, this is the x over t squared. It's the same as writing it 2t to the minus 2, which means, actually, let me write this straight. X equals 2 over t squared. This is the same as writing it this way. If I add dx over dt, I will get minus 2 times 2t minus 2 minus 1 minus 4t minus 3, which is the same as minus 4 over t cubed. Okay. All right. Ooh, time. 10 slides, 10 minutes. You think we can do it? Run. Okay, let's see. Run. Okay, so average speed, average velocity, instantaneous speed, instantaneous velocity. Okay, we have finished those. They're the same thing. One has a direction, one has no direction. Noor, I'm joking. I'm not actually going to run. I'm too fat to do that. Okay, so all right. What do we understand from these graphs? We have velocity, time graphs. Okay. Now, oh, these are running. Okay. Well, someone is running. All right. So we have graph number 1, graph number 2, and graph number 3. And what do these tell us? What do we understand from these graphs? Well, the y-axis gives us velocity, and the x-axis gives us time. Now, this person is running at a constant velocity of 2. Okay, no movement. No acceleration. This person is just, I don't know, maybe she's in a marathon. She's just moving at a consistent speed. No, actually 2 meters per second is very, very slow. Okay, so she's just walking. Now, the thief starts running, takes the bag, and continues speeding up. Okay, so he starts at 2 meters per second, which is the exact speed or the exact velocity of the old person, of the old lady, and keeps on speeding up. Okay, the policeman at this time at 0 is standing still because we're starting from 0. He's not moving, and he sees the thief running away. So what happens is he starts running and accelerating, trying to catch the thief. Okay, so the acceleration increases, constant acceleration, and this goes on. Now, many of you said something which is absolutely true. If this keeps going, this thief is getting away because his acceleration, which is the tangent here, is way more than this. Okay, let's map words to a position versus time graph. Kareem is initially walking due east. He stops, noticing a cat behind him. He runs due west and stops when the cat disappears into a farm. He starts walking due east again. Then the cat passes him and he runs due east after it. Kareem gets tired and stops running. Which of the following graphs correctly represents Kareem's position versus time? Well, let's do it one thing at a time. Kareem is walking. Okay, so the position, and he's walking east. East is up, west is down. Okay, so since he's walking east, the line should be going up. So maybe A is correct, maybe D is correct. This is wrong because this is walking in a straight line, not going east. This is also wrong. He stops, noticing a cat. behind him. Okay, stops means the tangent needs to be equal to 0. Both of them do this. D, D, A, D. Okay, let's see. He starts walking due east again. So he continues going east. None of them really tell us anything at the moment.
Doctor,
Yeah?
A and D are the same, but the difference should be he writes the time in the question. He should write the time that we know how much he is running for the east or to the west.
You are correct. Let's see if we can figure it out. Then the cat passes him and he runs due east after it. So if we say run, does he go west at all? Oh, wait. He runs due west. So he runs west. He runs west. He starts walking due east again. Ah, wait. This is important. He runs due west and stops when the cat disappears. Here, look, this is still going up, slightly up. Okay. Here, he properly stops, which means that D is the correct answer. Because he runs again, and this is a very, very large distance change in a very, very short amount of time. Okay, it's very good. A and D are very similar here. The only reason I chose D over A is because in D we have this flat area and in A we don't. So what is this change, this slope? Well, just like the change in position, we called it velocity. Here, the change of velocity, how fast our speed changes in a certain amount of time, we will call it acceleration. Okay, we will do the exact same math. Okay, but instead of delta x over delta t, we will do delta v over delta t. And we will get average acceleration. Okay. هو رجع مرة ثانية إلى east بعدين وقف. أيوة. So then the cat passes him and he runs due east after it. Kareem gets tired and stops running. Here he stops. Here he stops. Actually, the khat mustaqim here has nothing to do with whether he is walking straight or not. This is a graphical representation of position, not of exact position. Okay, so this is only telling us when we were children, we were كنا نلعب لعبة حار بارد. We would hide something, and someone else would need to find it. And the closer you get to that position, we would go har har har, or the further away you go, we'd say barid barid. Okay, the fact that someone is saying hot does not mean I need to go in a straight line. It means I am in the general vicinity. So the fact that this position is going east doesn't mean he's going east in a straight line. Okay. Okay, it doesn't mean he needs to. He goes in a straight line. It simply means that he is going in. Sorry, just a second. It just means he's going further east or further west. Okay. A and D. Okay. Let me look at this again, A and D. and at the beginning of next lecture, I'll go over this. Okay, but let's take a look at acceleration. So we look at the change in velocity, and okay, the average change in velocity is what we call average acceleration, and its unit is meters per second square. Okay, meters per second square, which literally means how many meters per second increase or decrease is there per second. Okay, what happens when we do the exact same thing and take delta t for acceleration to 0? We end up at the differential of delta v over delta t, which is dv over dt. Okay, now here's the interesting bit. A is equal to dv over dt, which is the same as, but v is already dx over dt, which means acceleration is the second derivative of position. بيرجع لكم كريم الليكتشر الجاي. Let me figure out is it A or D. أنا بنفسي صرت confused. Okay. So the acceleration is the second derivative of position. So we have position dx over dt is equal to v. dv over dt is equal to a. Okay. Eventually, these will stick, and these will be very useful for us in later chapters. I think we are running out of time. It is exactly 1:20. Let me see what is left. Interpretation. Okay. Let's call it a day. We will pick up from here. We will pick up from here, inshallah, the next lecture. Okay, with this, we only have enough stuff for about a minute or two, and we will continue to section 3.4. So to those of you who are following with the book, we have basically finished up until section 3.3. What is left? What is left is sections 3.4 onwards. We'll start, inshallah, section 3.4. The next lecture. Yes.
الحين الكتاب اللي ماخذينه من ستور الجامعة ما نذاكر منه توتوريال هذه الاشياء.
انا ما اعرف ليش الستور مال الجامعه عاطينكم هذا الكتاب اصلا. نحن قلنا لهم ان نحن مغيرين الكتاب. الكتاب اللي ستور الجامعه عاطينكم هو كتاب برتقالي اسمه هاليدي رزنك.
ايوه
هاليدي رزنك انترناشونال
برنسبل اوف فيزيك كذا.
ايوه ثواني خليني افتح الصوره عشان كل اللي محصلين الكتاب نكون على نفس الصفحه.
دكتور اصلا بعض الدروس ما في، يعني كم من درس؟
اي درس؟
يعني حفظت قوانين نيوتن، وهذا لا اول درسين، اول مع الميجرمنت
في الكتاب البرتقالي. انتم محصلين هذا كثير منكم ماخذين هذا الكتاب. هذا الكتاب اللي نحن كنا نستخدمه الفصول الماضيه وغيرناه الحين. احد الاسباب انه ثقيل جدا ثقيل. طيب الماتيريال كفرد از ذا سيم، وبالعاده الفصول الماضيه كثير من الطلاب طلبوا نسخ الكترونيه وما شابه، وصعب ما خصوصا مع الريموت ليرنينج ما كل الطلاب يقدروا يجون للجامعه يستلموا الكتب، فغيرناه الى اوبن ستاكس. الماتيريال كفرد are exactly the same.
يعني مثلا واجد ميجرمنت شابتر 1.
انزين خليني اوريكم شيء ثواني.
وهذاك ما في البرتقالي تقريبا شابتر 1 ما في.
ثواني صبر.
تمام.
خليني افتح فند open with اوكي. هذا كتابنا الحين. طيب راح افتح التيبل اوف كونتنتس ماله هنا على اليسار، وهذا الكتاب البرتقالي طيب اللي كثيرين مستلمينه، لان الكفر مختلف لكن الكتاب بتشوفوه نفس الكتاب اذا افتح. طيب المحتوى اللي موجود في الكتابين متطابق بنسبة 95%. في اشياء بسيطة مختلفة، طبعا اسلوب الشرح طريقة الشرح مختلفة تماما. طيب لكن الماتيريال نفسه. خلينا نشوف بوك ماركس. let's see chapter 1. زين، عندنا هنا chapter 1 measurements measuring things including length time mass. chapter 1 مال كتابنا معمق اكثر، فيه اليونت كونفرجن، فيه الدايمنشن اناليسيس، فيه الفيرمي كالكوليشن، فيه السيجنيفيكانت فيجر. هذا كله ما موجود في الكتاب البرتقالي. طيب chapter 2 vectors. هنا chapter 3 vectors، الترتيب مختلف لكن نفس الاشياء داخله: algebra products dot product cross product. اللي هنا chapter 3 عندنا، هناك chapter 2 شوفوا تقريبا نفس العناوين: position displacement average velocity instantaneous velocity speed acceleration constant acceleration free fall graphical. عندنا position displacement average velocity instantaneous velocity speed average instantaneous acceleration motion with constant acceleration free fall finding velocity displacement from acceleration. الماتيريال نفسه البرزنتيشن ديفرنت، الترتيب مختلف. طبعا الاسئله اسئله تماما مختلفه، بس بشكل عام 95 99% من اللي موجوده في الكتابين متطابقين.
لكن دكتور متعمق فيه اكثر شابتر 1 في الكتاب الاوبن ستاك.
كتابنا نحن متعمق اكثر، والكتاب اللي نحن معتمدينه الحين حال الكورس هو الكتاب الاخضر مال القذافي. زين الكتاب الاخضر اللي على مودل. طيب
تمام دكتور.
انزين ف this is the book we're going to be used on. السؤال هل مثلا ممكن نراجع الكتاب الثاني؟ طبعا ممكن نراجع منه. هل مفيد قراءة الكتاب الثاني اذا انا عندي وقت كافي واريد مثلا اشوف شرح بشكل مختلف؟ نعم مفيد. هل الاسئله اللي فيه مفيده؟ نعم مفيده. لكن الكتاب المعتمد هو الاخضر.
يا الله احنا نخلص هذا.
انا اعرف كل واحد فيكم عنده 4 5 مواد.
ايوه بالضبط. تمام دكتور.
لا نحن ما ندخل في السياسه، هذاك الله يرحمه القذافي، هذا نحن ما ندخل في السياسه، كويت ما كويت. Physics for Scientists and Engineering ايضا ايضا كتاب ممتاز. فاينمان Lectures for Physics، حال اللي يحب يطلع جدا جميل، واسلوب الشرح ماله مختلف عن اي كتاب فيزياء ثاني في العالم. فاينمان Lectures of Physics، يعني انا لما ما افهم شيء من كتب ثانيه اريد حد يشرح لي اياه من اول وجديد بطريقه مختلفه تماما، اروح فاينمانز Lectures of Physics. علي السلايدات موجوده على مودل اول باول. الكتاب فيه شرح وشرح زايد عن اللزوم بالعكس. وين هذا؟ كيف نذاكر من الكتاب؟ read it, read the important parts. عندكم هنا بين فترة والثانية عندكم أشياء مفيدة اللي هي شوف بداية كل سكشن في هنا هذا. ليش هذا مقلوب؟ الخط شوفوا سيدة ولا مقلوب؟ اوكي صار سيدة. Instantaneous velocity and speed، وبعدين تحته مكتوب learning objective. طيب ما دام تعرفون وفاهمين هذا الليرنينج اوبجيكتيف اموركم طيبه. في عندكم التعاريف هني سهله في المذاكره. عندكم ايضا اللي هو تشيك بوينتس، وعندكم examples. اذا if you go through these examples they're very useful. At the end of each chapter, right before the questions, you have chapter review, which is very good with a full summary of everything in this chapter.
دكتور وش رايك تحذف لنا
احذف ليش؟
مثلا في شابتر 1 الميجرمنت؟
ما ممكن، الفيزيكس بكبره معتمد على الميجرمنتس. if we don't measure how do we do things؟
يعني تخليه مثل الكتاب البرتقالي، هذا كان ما واجد فيه شرح في الميجرمنت نفس الكتاب الاخضر.
ايوه، لكن بعدين الطلاب كانوا يتورطوا بعدين في الشابترات التاليه. طيب خلينا نشوف ايش بعد. نقلل اللي نسويه في كل كلاس ونزيد المسائل. if I could I would. المشكله انه الكورس كبير، واذا قللنا من اللي كنا نسويه في كل هذا ما نلحق. اذا حسيتوا انه شرحي سريع جدا، مثل اليوم في واحده من البنات قالت لي، نسيت الاسم سوري، I have like 160 people here، اعتقد كانت يمامه، قالت لي انه you're too quick. I try to slow down. If I'm still too quick tell me I will slow down further. Okay. يعني نحن صحيح عندنا work plan، لكن إذا فاهمين لا تمشوا الأمور، إذا ما فاهمين لا تمشوا الأمور. قولوا نحن ما فاهمين، stop, go back, explain. Okay. We try to do as many problems as possible في التوتوريال. أمس مثلا في التوتوريال كنا جالسين للساعة 5:15. Okay, we did many problems. If you need even more, we can do some office hours. I will try my best. Okay, but unfortunately, we have 14 chapters to go through, which is a huge course. Yes, we will try to have questions as easy as possible in terms of language. أكمل الفراغ. It depends, but very rarely. Usually, it's calculations and multiple choice. نبهان, the book is موجود على هذا. Oh wait, which book do you mean? I have no idea what you're talking about. Chapter 1 مش حفظ. Okay, chapter 1 مش حفظ. Let me show you something. Okay, do not try to memorize chapter 1. If you have done yesterday's lecture, yesterday's tutorial, section 21, you will understand more the idea of chapter 1 in terms of هذا. If you have already done the homework problems for chapter 1, you will have understood that it's not about memorization. Okay. ترجمة لبعض الألفاظ not possible. That's against the rules. I will try to do office hours where possible. Problem is I have so many things to do. I am unable. Conceptual questions are good, but look more at examples. Zahra, Al-Yamama, give me a minute. Amani, it will be mostly multiple choice or very short answers. Okay, in terms of as in calculation, if that's what you mean by Maqali. To those who are saying chapter 1 is memorization, let me go to chapter 1 and very quickly go through it. Okay, let's look here. What are the learning objectives? What is the scope of physics? To explain everything, big and small. There's nothing to memorize. Order of magnitude and quantity calculations. In the tutorial, you will do some questions, you will understand. There is no memorization. Compare measurable length, mass, and time scales quantitatively. There is no memorization. It's about understanding. You know how I keep telling you, حد كتب في الامتحان أنه جبل شمس micrometers وحد كتب 50 million kilometers. We just need to understand the scale of things. There is no memorization. Okay, see, all of this is just general information. There is no memorization here. This table is by far the most important thing in this entire chapter. And again, this is not memorization. This is just for us to have an understanding. Okay. The idea of how models are built, that we have an idea, we build the theory, we test it, and if it doesn't work, we try again. We don't need to memorize what did Enrico Fermi did and what did Marie Curie did and when did she do it and what did he do and when did he do it. This is not geography or tarikh or هذا وطني. We do not memorize here. Okay. Units and standards. The whole point of 1.2 units of standards is to understand that we do things using standardized measurements. There's a reason why everyone uses meters or centimeters or whatever, because if we use non-standardized, we have a problem. What are these? Meters, kilograms, seconds, centimeters, millimeters, how to convert between units from big to small, small to big. This is the important part. Everything else is general information. How is the kilogram defined? What the definition of 1 meter is, how much light travels in 1/299,792,458 seconds. We don't memorize these. This is not what we do in physics. Okay. Unit conversion, yes, this is important. Dimensional analysis, yes, this is important. This was not in the Orange book, but I would usually teach it to my students anyway, because this is very, very important. Estimates, Fermi calculations, also important, but there's again nothing to memorize. It's the idea of how is it done. Okay, you'll understand more if you do the tutorial, if you're in section 22. Significant figures, you have already seen why is it very important in labs. Okay, so no memorization. Please do not try to memorize chapter 1 and the information in it. It is just useless. Okay. Noor, there are no solutions for check your understanding. If you have trouble, email me. I'll try to answer you. At the back of the book, there are the odd version. The odd numbers are at the back of the book. The even numbers, if you have an issue, you can email me. You can ask in the tutorials. Tutorial is the best place to ask about questions where you're having issues with. It's the best place. And you have, in many places, if you just Google the question, you will be able to see the answers. Okay, many websites have them. Okay. About 5. I wrote about 5.
دكتور اختيار multiple choice يعني.
Sorry, say that again.
Question for quiz.
Yeah, what about it?
يكون اختياري يعني والله مقال يعني كيف طبيعة الكويز بيكون؟
Most of it will be multiple choice, maybe one question. So you have 5 questions. So there will be between multiple choice and just short answers. So for example, calculate A dot B. That's a short answer. Yeah. A equals sine.
Yes.
Okay.
أكثر شيء ركز على الشابتر 2.
الهدف ما هو أنه يكون تعجيزي. Okay. الهدف أبدا ما أنه يكون شيء تعجيزي. It's only about understanding. Okay, we're not going to be putting questions just to make it just to make your life difficult.
تمام دكتور.
Okay, Dina, in cross products, whenever we're doing a cross product, Maria, by the end of this week, inshallah, you should have it released on Moodle. Yeah. Okay, the quiz is going to be out of 10 marks. And you have 7 quizzes during this, or 6 quizzes during this entire semester. All of them together amount to 10% of your course. Okay, so not one quiz equals 10%. All of them together is 10%. I honestly honestly don't have an example. I will try. Yes, Yom al-Khamis. I will actually release a survey in a little bit about the time, because I had sent an email about it being at 5 o'clock. I have received so many emails from students asking to move it to 6 o'clock, and so many emails from students asking to move it to 7 o'clock. Some students are having still classes at 5 o'clock on Thursday. فكرتي كانت أنه ما أريد أعطيكم شيء بعد التوقيت الرسمي. جتني واجد إيميلات تطلب أنه تأجيله إلى الساعة 7. محاضرة الساعة 8 في الليل عندكم، ولا قصدك أنه نعمل الساعة 8 في الليل الكويز؟ أوكي، إنزين، ممتاز. So I will release a survey. خلاص, I will release a survey today. Please vote in it. إنزين, based on the result of the survey, I will do it. If you're all happy with 7 or 8 o'clock, okay, choose 7 o'clock or choose 8 o'clock, okay, and we will do it at that time. Okay? All right. So I think that's it for today. Please don't forget to vote in that survey, and I will try my best to do it at the time that everyone chooses. Okay. Okay, so not 6 o'clock. I will give you multiple options. Basically, I will do 5, 6, 7, 8, and you choose them in the order that you like. Okay? All right, good luck to everyone, and I'll see you again the day after tomorrow in another lecture. فوضى. Okay, so I have another meeting. I'll see you all the day after tomorrow, okay? Have a good day.